Hello friends, welcome to Best Tutor. Today we are going to learn about all the four operations on rational numbers. What are the four fundamental operations of mathematics? They are addition, subtraction, multiplication and division. How are these performed on rational numbers? Let us get into the details one after the other. We have already learned what are rational numbers and how do we compare rational numbers. Let us get into the details of operations on rational numbers. What are the four fundamental operations of mathematics? The four fundamental operations on mathematics are addition, subtraction, multiplication and division. We will observe how are these four fundamental operations done on rational numbers individually, one after the other. Yes. How are two or more rational numbers added? Addition of rational numbers. Let us consider an example. One by 3 plus 4 by 7. First of all, is the sum of two rational numbers a rational number or not? Let us check it. 1 by 3 plus 4 by 7. How do we add it? As we have checked in the previous class, whenever we have to compare two rational numbers, we convert them into equivalent like fractions. Similarly, when we have to add two rational numbers, we convert them into equivalent like fractions. LCM of 3 and 7 is 21. The reason being 3 and 7 are co-prime numbers or they don't have any common factor. So, I will take it as 21. How can I convert 1 by 3 as a fraction with 21 as the denominator? I need to multiply the numerator and denominator with 7. So, we get 7 by 21. Similarly, the second rational number is 4 by 7. With which number should I multiply 7 in the denominator to get 21? We need to multiply it with 3 both in the numerator and denominator. So, we get 4 into 3 is 12, 7 3s are 21. So, we have changed 1 by 3 as 7 by 21, 4 by 7 as 12 by 21. So, we have 7 by 21 plus 12 by 21. These two are like fractions. Addition of like fractions is very simple. We are going to take the common denominator as the denominator of the solution, add both the numerators to get the answer. 7 plus 12 is 19, denominator is 21. So, the answer of 1 by 3 plus 4 by 7 is 19 by 21. Now, I posed a question in the starting of the session. Is the sum of two rational numbers a rational number? We have got the sum here. Let us check whether this is a rational number or not. For a number to be a rational number, it has to satisfy three conditions. What are the three conditions that it has to satisfy? It should be written in the form of a fraction. Is this in the form of a fraction? Yes, of course. Second one, both the numerator and denominator should belong to integers. Are both 19 and 21 integers? Yes, of course. And the last condition is denominator should never be equal to 0. Here the denominator is 21, which is not equal to 0. Therefore, the answer or the sum of these two rational numbers is also a rational number. Let us look into another example. If at all if this is the example where we have to find out sum of 3 rational numbers, how do we go about? The procedure remains the same, but you have to find out the LCM of all the 3 denominators, 3, 9 and 5. Let us look into the easier procedure. The highest denominator is 9. Let us read out 9 table. 9 ones are 9. Is 9 divisible by 3? Yes. Is 9 divisible by 5? No. So 9 is not the LCM. 9 twos are 18. Is 18 divisible by 3? Yes. 3 6 are 18. But is 18 divisible by 5? No. So 18 is not the LCM. 9 threes are 27. Is it divisible by 3? Yes. But not by 5. So this is also not an LCM. What about 9 fours are 36. Is 36 divisible by 3? Yes. 36 divisible by 5? No. 9 fives are 45. Is 45 divisible by 3? Yes, of course. And 45 is divisible by 5 too. Therefore, 45 is going to be the LCM of 3, 9 and 5. I would like to add one more point here. Any number which is divisible by 9 will automatically be divisible by 3. So in this step, even if you won't check whether it is divisible by 3 or not, doesn't make any difference. You can directly check whether it is divisible by 5 or not. Right. So we have found out that the LCM of 3, 9 and 5 is 45. Right. So we need to convert all these 3 rational numbers as rational numbers with 45 as their denominator. We'll convert each and every rational number initially. I want 45 as the denominator. So with which number do I multiply this rational number both in the numerator as well as denominator? 3 into 15 is 45. So 2 into 15 is 30. The first rational number 2 by 3 has got converted into 30 by 45. How about 4 by 9? 4 by 9, I want the denominator to be 45. 9 into dash is equal to 45. We know that 9 5s are 45. So 4 into 5 is 20. And the last number is 1 by 5. Last rational number is 1 by 5. I would like to convert this into a rational number with denominator 45. 5 into dash is equal to 45. 5 9s are 45. So the numerator has become 9. Now the 3 rational numbers have got converted into 3 equivalent like fractions. So the sum becomes 30 by 45 plus 20 by 45 plus 9 by 45, which is nothing but the common denominator becomes 45. The numerators will be added individually. 30 plus 20 plus 9, which is going to be, yes, the sum is going to be 59 by 45. Can I leave the answer like this? No. Always the answer should be a proper fraction or a mixed fraction. This is an improper fraction. So immediately we have to convert it into mixed fraction. How do we convert it into mixed fraction? Divide 59 by 45. 45 ones are 45 and the remainder is 1. So it's going to be quotient QR by D. So 1 14 by 45. This is the procedure to add a set of rational numbers. How about subtraction of rational numbers? How about subtraction of rational numbers? Example 1. 4 by 3 minus 2 by 5. 4 by 3 is a rational number, 2 by 5 is a rational number. How do we subtract? The procedure remains similar to that of addition. Initially we have to find out the LCM. LCM of 3 and 5 is 15. So I have to convert 4 by 3 as a rational number with 15 as the denominator. So how do we convert 4 by 3 as a rational number with 15 as the denominator? 4 by 3 is equal to 4 by 3 into dash. What am I supposed to do here? I have to multiply both the numerator and denominator with some number so as to get 15 in the denominator. 3 into 5 is equal to 15. So 4 by 3 has become 20 by 15. 2 by 5. I want the denominator to be 15. So 5 into 3 is equal to 15. So the answer, or the rational number 2 by 5 has become 6 by 15. Now the entire subtraction has been changed into a simpler question. It's going to be 20 by 15 minus 6 by 15. The common denominator is 15. 20 minus 6, which is 14 by 15. Is it a rational number? Does it satisfy all the three conditions? The first condition is it should be in the form of a fraction. Yes, of course, 14 by 15 is a fraction. The second condition, both the numerator and denominator should be integers. 14 and 15 both are integers. Third condition, denominator should never be equal to 0. Here the denominator is 15, which is not equal to 0. Therefore, 14 by 15 is a rational number. Hence, it is also proved that difference of two rational numbers is going to be a rational number. So, we have learned addition and subtraction of rational numbers. The third operation is multiplication of rational numbers, which is going to be very simple. Multiplication of rational numbers. Let us consider an example. Four by 9 into 3 by 10. Let us consider only two rational numbers. Yes, of course, these are rational numbers. Now, how do we find out the product of these two rational numbers? There are different steps. First step, check if there are any common factors of the numerator or denominator. May not be of the same rational number, but may be the other rational numbers also. If we observe, 4 is the numerator of the first rational number, 10 is the denominator of the second rational number, but they have a common factor 2. So, let us cancel the common factor. 2 2s are 4, 2 5s are 10. Similarly, if we observe, the denominator of the first rational number and the numerator of the second rational number have a common factor 3. Let us cancel those also. So, we have 2 by 3 into 1 by 5. So, the first step is to cancel off the common factors. Second step, after cancelling the common factors, the product is also going to be a fraction or a rational number, where the numerator is going to be the product of the numerators of the given rational numbers, and the denominator is going to be the product of the denominators of the given rational numbers. So, that is going to be the third step. Now, how do we find out? 2 1s are 2, 3 5s are 15. So, this is a procedure to find out product of two rational numbers. What if we have more than two rational numbers? And what if we have rational numbers of opposite signs? Let us consider this example. Minus 2 by 9, 3 by 5, 10 by 20, 27. Right. Here we observe that one of the rational numbers is negative and the remaining two are positive. Never mind. But the procedure remains the same. What are we supposed to do? If we remember the previous example, there are 3 steps. First step, find out if there are any common factors. Do we find any common factors here? Yes. 2 does not have any common factors in the denominators, so we will leave it off. But 9 has common factor 3. 3 ones are 3, 3 threes are 9. And similarly 5 ones are 5, 5 twos are 10. So the first step is done. Cancelling of common factors is done. Now let us move on to the next step. Including the sign, we will take the product of the numerators and denominators. Let us check if we have forgotten any common factors. No. So minus 2 into 1 is minus 2. Minus 2 into 2 is minus 4. The numerator of the answer or the result fraction is a rational number is minus 4. Denominator 3 into 1 is 3. 3 into 27 is 3 sevens are 21. 3 twos are 6 plus 2 81. So if we follow the step by step procedure, we have got the solution of the product minus 2 by 9 into 3 by 5 into 10 by 27 is minus 4 by 81. So the question remains the same. Is the product of 2 or more rational numbers a rational number again? Let us check it. Does it satisfy all the 3 conditions? Yes, the first condition is it should be in the form of a fraction. Yes, it is in the form of a fraction. Both the numerator and denominator should be integers. Yes, minus 4 is an integer, 81 is an integer as well. Last one, denominator should never be equal to 0. 81 is not equal to 0. So this is a rational number. So we have got product of these set of rational numbers, which is also a rational number. Now the last operation on fundamental operation is division of rational numbers. Division of rational numbers. How do we divide 2 or more rational numbers? Minus 3 by 10 divided by 2 by 5 is the question. The best principle to be followed in mathematics is convert the complex problem to a simple problem. Division appears to be a little complex, multiplication appears to be very simple. So my aim is to convert this complex problem of division into a simple problem of multiplication. Yes, minus 3 by 10, and I have replaced the division symbol with a multiplication symbol. We cannot change the question, but we can change the way it appears without changing its meaning. Minus 3 by 10 divided by 2 by 5 becomes minus 3 by 10 into the reciprocal of the second rational number. So it's going to be minus 3 by 10 into 5 by 2. Now multiplication is very simple. First step, let us follow the step by step procedure. Do they have any common factors? 3 and 2 do not share any common factors. But 5 and 10, yes, they have a common factor 5. 5 ones are 5, 5 twos are 10. The second step says that the answer is going to be a rational number with the product of the numerators as the numerator and the product of the denominators as the denominator. So the solution is going to be minus 3 by 4. Again, is it a rational number? Yes, of course, it follows all the 3 conditions. So this is the procedure. Now what if at all minus 2 by 5 has a negative symbol? The procedure remains the same, but every case the second fraction carries a negative number, negative sign. So here minus 3 into minus 1 becomes plus 3. That's the only difference to be taken care of. So this is a procedure to find out a quotient of two rational numbers or division of rational numbers. Thank you. Let us meet in the next video.